In the last podcast, we took the formula for a function and we used it to make a graph. In fact, we used it to make 2 or 3 graphs. In this podcast, we asked the question, suppose we already have the graph, is there anything we can tell about the function? Well, let's take a look at the first graph here. The question says, is this relation a function? Now, the relation that we've graphed is that circle shape there. We've graphed a bunch of ordered pairs and they've formed up in the shape of a circle. And we want to know, is that graph the graph of a function? Now, we know the definition of a function says for each x, for each first element, there can be one and only one second element. So here's our procedure. I draw a vertical line right through the number x1 right here. Oh God, what is this? Pen's playing tricks on me here. I draw a vertical line right through this number x1 and notice that it hits the circle here and it hits the circle here. If I look at the corresponding y here, it would be this y right here on the axis. If I look at the corresponding y here, it's this y down here, y1. So this point would be the point x1, y1 on the graph. This point would be the point x1, I'm still the same distance to the right, y1 on the graph. Notice that for the same x1, I get 2 different y's. That means this is not the graph of a function. I ask the same question about the second graph. And again, I take the same procedure. I go to x1 and I draw a vertical line. And I see, well, on the graph, what y would correspond to this x? And I see that it's y1. This would be the point x1, y1. x1 to the left, y1 down. I go to another point of the line. I draw another vertical line. I draw it through x2. And I try to see the y that would correspond to that, so I come out this way and find that it's y2. So this would be the point x2, y2. Notice that I did, for the value of x, x1, I got only one value of y, y1. For the value of x, x2, I got only one value of y, y2. How did I get 2 values over here? Well, when I drew the vertical line over here, I hit that graph in 2 places. And the upper place produced this y2 value, the lower produced this y1 value, both corresponding to x1. Now that consideration and looking at these graphs leads us to an important conclusion about functions. And that's given right here. It says if no line drawn vertically through the x-axis intercepts the graph of a relation at more than one point, then the relation graphed as a function. No matter where I draw a line here. I only hit the graph at one point. There's the y that corresponds to this x. And no matter what x I go to, there's only one y that will correspond to that x. So that's called the vertical line test. If no matter where you draw a vertical line, you only hit the graph once, we say the graph is the graph of a function. Now, is there any other kind of information we can get from a graph? Well, there's just all kind of things if it's a pretty good graph. Take a look at this graph down here at the bottom. I ask a whole series of questions. The first one I ask is, what is f of negative 2? Now remember, in our notation, y is equal to f of x. So in this case, the negative 2 is the x. And the f of negative 2 is the y. So what I'm asking you in point A is, if x is negative 2, what is y or f of x? So I go to where x is negative 2. That's right here. To see what y is, I come down to my graph. I hit this point right here, and I come over to read my value of y, which is right here. So I would say f of negative 2 is 4. Excuse me, negative 4, because it's 4 down. 4 down from the x-axis, so that would be a negative 4. Now the next question says, well, what is f of 4? Remember, the 4 is the x. The f of 4 is the y. So I'm saying when x is 4, what is y? So I come over here to x is 4. 1, 2, 3, 4. I read up on the graph. The graph is up here. what value of y does that correspond to? That one right there. So f of 4 is 2. Now I say, well, suppose f of x was 4, what would x be? Remember, f of x is y. Where is y4? Well, y4 is right here. Is there any point on the graph that reaches that high? Well, this point reaches that high. Well, what is x? It says x equals what? Well, come down from that point to right here. X is equal to 5 to the left, or negative 5. The next one says, what is the domain of f? Remember, the domain is the x's. What are all the x's that appear in an ordered pair for this function? And a way you could do that is just to collapse this function back on the x-axis. This point would fall onto x equals negative 5. This point would fall onto x equals negative 2. This point would fall onto x equals, well, this point would fall onto x equals positive 1. And then the arrowhead here means the graph just keeps going and going. So this point would fall onto this x, and points would continue to fall on x's all the way out to infinity. So what x's got covered? Well, to the left, the last x that got covered was this 5. We know it's last because of this dot right here. When I put a dot on a graph like that, it means the graph stopped there, if the dot is at the end. And the arrowhead here means the graph never stopped. It kept going that way, and it kept going that way. Well, if it keeps going that way, that takes us to positive infinity, but we stop at negative 5, so the domain would be negative 5 to infinity. What is the range? The range is the only time you ever look on the y-axis for an interval. I'm going to ask you for lots of intervals. The only time you look on the y-axis is the range. Collapse this over to the y. The highest the function ever gets is 4. How low does it get? Well, the arrowhead means it just gets lower and lower and lower and lower. And so that goes to negative infinity, so we would say negative infinity to 4, not 4 to negative infinity, because the smaller number always goes on the left, bigger number on the right. X-intercepts are where the graph hits the x-axis. It hits the x-axis here. It hits the x-axis here. It hits the x-axis here. Those are all x-intercepts. So if I ask you for the x-intercept, you would say negative 4, 0. This second point would be 2, 0. Notice all the y's are 0 at the x-intercept, and 5, 0. If you give me a y that's not 0, then that's not an x-intercept. And then it says, well, what is the y-intercept? Well, the only place the graph hits the y-intercept is here. That is, x is 0, y is negative 3. So when you got the graph of a function, you can tell a lot about the function. We'll see even more in the next podcast.